Have you ever imagined a ball passing through a wall instead of bouncing back? Sounds impossible, but in quantum world, it happens every moment. This year's Nobel Prize in Physics 2025 celebrates that mystery called quantum tunneling. Three scientists, John Clark, Michel Deborah, and John Martinez, have built circuits that let us actually see quantum mechanics at work. Their groundbreaking experiment proved that electron can tunnel through barriers and that quantum behavior exists even in electrical circuits, not just in subatomic particles but at macroscopic level. This discovery bridges the gap between the invisible quantum world and real world technology, laying the foundation of superconducting qubits and quantum computers, the future of computing power itself. So, how did they make the invisible quantum world visible? Let's understand the science behind the Nobel winning discovery. The story goes back to, let me just find out my pen. The story goes back to 1980s, and what they did actually, they were trying to, trying to find the answer of an open question whether a macroscopic circuit would show quantum behavior at all. And what happens, अगर आप लोगों को थोड़ा भी आइडिया हो, in 1926 the quantum mechanics, 1920s even, quantum mechanics was developing, and this guy Schrodinger, who gave his famous equation called Schrodinger wave equation, which says electrons both not only as particle but wave also, and this particular thing is called, which I am writing in scientific notation, this is called wave function. Quantum mechanics is different from classical mechanics in a sense, it is probabilistic in nature. Yes, so अगर आपको थोड़ा भी आइडिया हो तो classical physics is deterministic but quantum mechanics is probabilistic, and this behavior of quantum tunneling is like this. Suppose there is a mountain, this mountain, and in this mountain, if you want to cross this mountain, what you need to have actually, you need to have enough energy. But suppose you don't have energy, or instead of climbing this, you want to climb this energy, right? But you don't have enough energy to climb it and then go down. So what you do, you tunnel through like this, you tunnel through like this. Again, as I have talked in my introduction, suppose there is a wall. Another example could be, suppose you have this wall and you throw a ball straight to this wall. What will happen? What do you expect in classical physics? The physics which we see around, what do you expect? This is your tennis ball, suppose, and you are throwing this tennis ball onto this wall. What do you expect? I think you expect, or what we expect actually, we expect this ball going back, like this, okay? But in quantum physics, if the particles are very, small, subatomic particles, like for example, electrons, if this barrier is, we have nucleus of an atom. This is a model of nucleus of an atom. So what happens? Some particles, they can pass through, they can cross this barrier, like alpha particles. And if you know about alpha particles, we have made another video. They are helium nucleus. So this is what is the quantum tunneling actually. Quantum tunneling, there is some probability if this barrier is small, not very large, but this barrier is very small, it means its energy is not too large, then there is some probability this particle, this subatomic particle, this pass through this barrier. But in classical physics, it doesn't happen. Classical physics mean macroscopic world, which you and me see. These guys, what they did actually, they proved that entire electrical circuits and the circuit which you can जिसको आप हाथ पे पकड़ सकते हो, at least that big, this circuit can effectively obey quantum mechanical laws. They use something called Josephson Junctions to observe tunneling and energy quantization. There is some thing is called quantization. For example, if we were to talk about energy of a photon, photons are particle of lights, their total energy is equal to h nu, right? And this energy is quantized. It means it is not continuous, it is in discrete टुकड़ों में. और their findings underpin superconducting qubits. Qubits are the units of quantum computers. We are going to talk about it. Quantum sensors and precision measurement technologies. तो अगर हम बात करें what is this breakthrough, these the three trio proved macroscopic quantum tunneling not just with subatomic particles but with entire electrical circuits. So for example, They design circuits with two superconductors. These are superconductors. There are certain metals at, there are certain metals, if you if you cool them down around 0 Kelvin. Remember, 0 Kelvin is unattainable. It is, if you know about it, it is unattainable temperature. You cannot attain it in laboratory. Unattainable temperature. This is the law of thermodynamics, and this is by definition minus 273 degrees Celsius almost, 273.15 I guess, but it is minus 273. So you can go around minus 270s, maybe 72, and certain metals, they behave like superconductors. When you super cool them, they build circuit around them and they will carry current with no resistance, and therefore they are called superconductors. So there is one insulator layer which is called Josephson junction. This junction is called Josephson junction, and the current is there, because insulator will stop current in ordinary world, but the current goes, from there to this place to this place. There are some technicalities, we don't need to get into technicalities, but this behavior at near absolute zero temperature confirmed that macroscopic system could exhibit quantum coherence. This is what the discovery is all about. And so if someone says, what is this Josephson junction? This is the fundamental unit for this year's Nobel Prize. Two superconductors which are separated by ultra thin or very thin, this is very thin, ultra thin insulators. And these scientists wanted to know if a parameter of the circuit as a whole, in this case the junction's phase difference, something called technically phase difference, could behave like a single quantum particle, and if it is so, then can it show macroscopic quantum tunneling? And they found that yes, it showed macroscopic quantum mechanical tunneling and discrete energy levels, which we are saying quantum quantization, So discrete energy levels were there, and the current passes through this junction, right? So this is for what this year's Nobel Prize was given. What is this experiments and discovery all about? This was conducted at University of California in 1980s. They demonstrated that current could tunnel through an insulating barrier, which I am saying, Josephson junction, which is an ultra thin insulating layer between two superconductors. They showed quantization of energy levels in the system and discrete quantum states. Discrete means simple quantization, right? Quantization simply means discrete things. Tukdo mein matlab, it is not continuous. Okay, that marked the first observation of quantum tunneling in engineering and visible scale at electronic scale. This is the idea. What is technological significance of this Nobel discovery? These circuits allowed precise quantum control and measurement. So let me tell you a brief idea. जो normal computers होते हैं उनके पास दो type के binary digits होते हैं, 0 and 1. So either 0 and 1 simply means, for example, 0 volt or 1 volt. It means we say either voltage is high or voltage is low, never between this. But these qubits, they are superposition of these two, there is possibility. Suppose there are two qubits की दो अगर states हैं, say psi 1, psi 2. These are technical, notations. So they can be the superposition of these two. कोई ऐसी भी हो सकती है जिसमें psi 1 का भी mixture हो, psi 2 का भी mixture हो. That is what makes these qubits different from the ordinary computers. They can be used as quantum sensors, superconducting qubits, low noise amplifiers, and precision electronics. Such applications have transformed quantum computing, medical imaging, and metrology. That is the technological significance. Why this discovery matters? The experiment proved that quantum mechanics applies not only to subatomic particles but also to macroscopic system like electrical circuits. That is, this discovery was all about electrical circuits which you can hold in your hand, like the circuit chips. It showed quantum coherence and tunneling can persist even in large system, an important milestone in quantum technology. So this is what they were looking for. This has revolutionized modern quantum computing, making it possible to manipulate and read quantum states in engineered, circuits. Their findings connect fundamental physics to practical applications, bridging pure science with emerging technologies. This is why this discovery matters. And What is the implication for India and science policy? India's growing focus है ना, अगर आप लोगों ने पढ़ा हो नेशनल क्वांटम मिशन, so India's growing focus on quantum mission, which is National Quantum Mission 2023 to 2031, aligns with such breakthroughs. This research inspires advanced in quantum communication, encryption, precision sensors, critical for national security also. You know, if you come across newspaper, you might have read about randomness, you know, which is important for encryptions, national security also, so which uses quantum mechanics. Also highlights how basic research not driven by immediate utility. Okay, तो basic research का ऐसा नहीं कि आज ही फायदा होगा, it can yield transformational technologies later, and a key lesson for India's R&D finding approach. So this is today a brief video about Nobel Prize in Physics. And before we wind up this video, let me give you quickly the terms which can be helpful for your preparation. So what is quantum tunneling? Quantum tunneling is basically phenomenon where particle cross energy barrier they cannot classical overcome. For example, if you throw a ball onto a wall, it bounces back. It doesn't go away, right? It doesn't pass through. Josephson Junction is what? A superconducting device separated by ultra thin insulator allowing tunneling current. Okay, there are two superconductors and there is this, you know, barrier, but insulating barrier, but current, you know, there is probability that current will pass through between this insulating, you know, ultra thin layer. What is superconductivity? Superconductivity means zero electrical resistance below critical temperature. Remember, it is at which is sometimes called cryogenics. Cryogenics is low temperature physics. Cryogenics is about low temperature physics. Okay, so it is low temperature physics, and this superconducting conducting behavior is around at minus 273 Kelvin, which is unattainable but near minus 273. Macroscopic quantum phenomenon, quantum effects observed at visible scale, for example, electrical circuit which you can hold in your palm. Quantum coherence means maintaining quantum states over time, essential for quantum computing. So coherence simply means here maintaining quantum states. And what is SQUID? Quantum superconducting quantum interference device are called SQUID. You know, this is important for your exam. They are used for ultra sensitive magnetic field detections. So this is it in this video. Finally, I am giving you one question for practice. The 2025 Nobel Prize recognized experimental evidence of quantum tunneling in superconducting circuits. Explain the significance of this discovery in advancing quantum technology and its implications for the India's national quantum mission. You should write it in 250 words. So we wind up this video. If you like this video, don't forget to hit like button. Don't forget to subscribe the channel and let us know how do you feel about this video. Thank you so very much. See you guys until next time.